Good morning students. In this video session, I am going to teach the third illustrative example which is present in your syllabus, okay, in the first unit, okay. So what's the illustrative problem here is, guess an integer number in the range. Guess, what is guess means? You have to think one number. Which number? Integer number, okay. So you have to think one integer number. For example, what is integer number? 1, 2, 3, 4, 5, infinity. You have to take any one number, you have to guess it in the range. Range means a border. 1 to 100 means, for 100 is your range means in between 1 to 100 or 0 to 100 you have to guess one number, okay. This is the what the concept you are going to learn here means, in the childhood you will play with your friends, you told to guess one number, then you will find whether the number is correct or not, right? The same concept here we are going to do. The thing is, here the computer will generate a random number. Computer will generate any one number randomly, okay. Then as a user I am going to guess one number, then the particular program or algorithm or pseudocode will check whether my guess number and the computer generated random number is equal or not. If the guess number, my guessing number is less than the computer generated random number means it will say it is low. If my guess number is greater than the computer random generated number means it will say it is high, your guess is high. If it is equal, it will say your guess is correct. This is the logic, okay. Like your childhood game, you want to guess one number, then computer will randomly select one number, it will be compared and it will give the answer, okay. So guess an integer number, one integer number in the range. For that we are going to see about the algorithm, pseudocode and the flowchart, okay. So first, algorithm. As per the what's the algorithm rule? First you have to start the algorithm, then get the random generator number as n. That is nothing but computer generated number. Computer is randomly generating one number, that number is n. That number is n. For example, it is 10. Then read the guess number from the user. User means ourselves, okay. I am guessing one number. For example, my guess number is here 5. Next step is you have to compare the guess number. What's the guess number? Guess number is 5. So 5, compare means you have to check the condition, if condition. You are comparing, you are checking, okay. So compare 5 greater than 10. Whether the condition is true, 5 greater than 10? No, the condition is false. If the condition is false means, true means guess is too high, it is false. So it is checking another condition. As the condition is false, if it is true means it will print guess number is high. Yes, the condition is false here. So you are checking the another condition. Here it is if. You are checking the another condition, else if. Okay. Here, what's the next condition? Compare guess. Guess is 5. Less than, your computer generated number is 10. 5 less than 10. So this condition is true. So what will happen? It will print the number is low. Okay. Suppose your guess number is 10. Else if your guess number is also 10, the third condition, okay, and your computer generator number is also a 10, then we say it is a correct. See, otherwise guess is equal to n, that is here now the guess is 10 and n value is also 10. At that time it will display your guess number is correct. All of you got it? You are guessing one number, computer is randomly generating one number, then we are comparing both the number by 3 conditions. If it is greater, if the guess number is greater, you have to say guess is greater than n. If the guess is less, we have to say your guess is less than the computer generated number. If both are equal, we say the guess is correct. At last, stop. All of you got it? For the same program, for the same problem, we are going to see the pseudocode here. Okay. Pseudocode means we are following the rules and regulation. It's a imitation code, right? So pseudocode means it's a false code. It's like a programming, but it's not the program. It's like the programming code, but it's not a program. That's what we say, it is a pseudocode, false code. But it has some rules and regulation. We have to write with the form of keywords. Lot of keywords you studied in the previous video sessions, right? So first, for denoting the start, we have to use the keyword begin in the capital letter. All the keywords should be in the capital letter. So begin is the starting position. Then indentation. What is indentation? We have to give the space to denote the what are the line comes under the begin. Okay. See, these all lines are, these everything is comes under the begin. So we have to follow the indentation. Then read guess. Guess means user input. Guess is nothing but user input. Okay. And what is n? This is computer input. It is computer input. Guess means user input and n is computer randomly generated input. If is a keyword. If I am comparing guess is greater than n. If this condition is true, here we saw, right? If guess is greater than n means it will print guess is high. Suppose if this condition is false, true means this statement will be executed. False means it will come to the next if condition, else if guess less than n. Suppose your guess number is less than the computer generated number means it will print guess is low. Again, if this condition is true. Suppose again it is false, it will check the third condition. Okay. Print guess is correct. It's nothing but we are checking guess equal to n. Okay. Here we are checking else guess equal to n. If this condition is true, we will say print guess is correct. Then we have to close the end if. Okay, your if is started here and ended here. So end if. Then you have to close the begin. Your begin is ended here. This is the last point here. Instead of stop, you have to use end. All of you got it? Then we are going to see the flow chart. Okay. How to draw the flow chart for the same illustrative problem. Okay. First, this oval symbol is used to denote the start. Oval symbol is used to denote the stop. And stop, for stop also you have to use the oval symbol. Then this parallelogram symbol. What's the need of parallelogram here? Parallelogram symbol is used to get the number. You denoting the input and output statement. Read means you are getting. So you are getting the input. Read guess from the user. Then n from the computer. So two numbers we are getting as the input. That's what we are using parallelogram symbol here. Then what is this diamond symbol denotes? Diamond symbol denotes decision statements. For checking a condition we are using diamond. So what's the first condition? Whether your guess number is greater than the computer number, computer random generated number. True means what will happen? Guess, we have to print guess is high. Your number is greater than the computer generated value. So you have to think, oh, we have to select the less number. Suppose you give the less number means we have to print it is less number. So it will be a repetitive thing. We have to check whether it is greater or less or equal. Till that it will work. Okay. Then suppose if the condition is false means it will check the another if condition. Guess less than n. Okay. So your input is less than the computer value, computer generated number. If it is true, we have to print guess is low. So you have to think we have to guess some higher number than this. Okay. So again, if this condition is false, we are checking the another condition, that is the else statement. Okay. Whether the guess is equal to n. If the guess number is equal to n, we say it is correct. Okay, either it is less or greater, okay, otherwise it will be equal. That's what we are not checking a condition here. Okay, then what is this symbol? Connector symbol. Multiple flow lines are coming, right? So you have to use the connector symbol, then you are stopping the flowchart. All of you got it? So in this illustrative example, we saw the algorithm, then pseudocode, flowchart for guessing an integer number in the range. I hope you all understand this. Thank you, students.